when I start trigonometry, I try to go a little bit slower just because it might seem that going over angles and drawing angles is very basic, but I promise you, if you don't know how to do this stuff, then the trigonometry is going to be like, whoa, what is going on here? Okay, so I really want to get us used to drawing angles, figuring out what they are, and things like that. Okay, so let's just go over what we went over last time. We said that angles can be in any kind of direction, but the way that we drew angles was where the x-axis or the positive x-axis is our initial side or the side that we start our angle from. Okay, so our angle will always be facing kind of to the right. Okay, now the terminal side or the side that we end at can be anywhere else in the graph. Okay, but we always start our angle at the initial side and we kind of move over to the terminal side. Okay, now we can do that in two ways. We can either go counterclockwise or we could go clockwise. Which one is positive, counterclockwise or clockwise? Counterclockwise, right? It's kind of weird to think of it that way. Usually you think of an angle going clockwise because of the clock, but counterclockwise is a positive angle in this class at least. Okay, we did a couple examples and I told you that the four main angles that are really important in a graph are, well, 0 degrees, right? Not going anywhere. 90 degrees, which is our basic 90-degree angle. If we go even more, 180 degrees, and then 270, and then finally going around is 360 degrees, right? So there are four main angles that we had to know where they are in order to draw like other angles in between. And the way that we did that was, well, before I go into that, okay, yeah, let's take a step back. Whenever we have an angle like -200, it's kind of hard to draw -200 as an angle, right? This is why we have coterminal angles, which are found by either adding or subtracting 360 degrees to go around the circle. And it gives us an angle that goes the opposite direction, but is still the same picture, right? So instead of -200, I could just draw 160, and that's easier to draw than a negative angle. Okay, so in order to draw these, we did a couple examples, and I think we learned that drawing positive angles are really easy, right? You just figure out, okay, which quadrant is the angle going to be in, and then I know I'm going to go counterclockwise, and that's it. When we got to negative angles, it got a little bit weird, especially like figuring out how to draw them, right? We figured out, okay, we need to draw -32. I told you there were two ways to draw this. I'll start with way two. Way two was kind of relabeling your axes, going the opposite direction. Normally we go 0, 90, 180, 270. If we're going the opposite direction, it would be 0, -90, -180, -270. You can use, you can kind of think about, okay, what quadrant is my angle going to be in, and then draw it that way. The way that I kind of like, because it's a little bit easier for me, is to just find a coterminal angle, okay? So if I wanted to find -32, I would just add 360 to get a positive angle, and then I would just draw that angle and know that I'm going clockwise. Okay, if that didn't make any sense, let's just do number 4 here, okay? Now, I'm gonna use way number 1 here, just because I think it's a little bit easier for me. And the way I'm gonna do that is think about my angle as 0, 90, 180, and 270, okay? And then 360 again, okay? So I wanna draw -189, which means, okay, this is a negative angle. I like drawing positive angles. How can I get -189 in terms of a positive angle? What should I add to it? 360, right? 360 will give me a positive coterminal angle. So what I'm going to do is I'm going to do -189 plus 360. And well, that's going to give me a 171. Okay. So I know that a positive coterminal angle for -189 is 171. Okay. So taking a look at this, is my angle going to be in quadrant 1, 2, 3, or 4? 2, right? Because 171 is between 90 and 180. It's actually very close to 180, so maybe I should draw my angle here. Okay, so that's my terminal side. Okay, well, I'm not drawing the angle 171 because that would be going counterclockwise. The angle is negative, so I really need to make my angle counterclockwise. Okay, so I'm going to start at my initial side, and I'm going to go in a counterclockwise direction to the line I just drew. Okay, so that's the way I like to define angles. Okay, any questions on number 4? All right, moving on to number 5. Let's use way number 2 to find this one. Okay, so I'll show you what I do for this one. Using way number 2, instead of labeling my axes like the normal way, I know that this is 0. Going, clockwise, this would be negative 90. Going clockwise again, we have negative 180, negative 270, okay, and then negative 360. Okay. All right, thinking about my, quadrants, is this angle going to be an angle or quadrant 1, 2, 3, or 4? 3, right? Because negative 92 is between negative 90 and negative 180. So here I didn't even need to find a coterminal angle. I know that it's between negative 90 and negative 180, closer to negative 90. So I know my angle has to be maybe a little bit closer, maybe like that. Okay, and I'm still going clockwise because I'm having a negative angle. So I'm going to start at my initial side and at my terminal side. That's what my angle looks like. Okay. Any questions on number 5? All right. It doesn't matter to me what method that you use to figure out how to draw angles. Yeah. Yeah. Mm-hmm. Righty. All right. Okay, here's where things get a little bit crazy. When we do calculus, or sorry, when we do algebra, and eventually, if you ever take calculus,
I have a feeling I know.
yeah, you know it's about to happen, and it's not even the full part, which is kind of the sad part about it, but we're getting there. When you eventually go further into mathematics, especially in the trig section, there's going to be very specific angles that we use that are really important to know how to use and apply in different scenarios. So I'm going to show you a couple important degrees that you're going to have to know where they are. You're not going to have to guess where they are. Like you're going to be like, okay, I know that this angle is here, and I know that that angle is there. And we call these important angles. Okay, what I have here, it looks kind of weird. It's an X and Y axis, but on top of it, I drew a circle. Okay. And this is a very special circle because it has very specific coordinates on it. Okay. I'm going to give you 4 coordinates today, but we'll learn more of the coordinates later. Okay. This thing that's special about the circle is that the radius of the circle is 1. Okay. So halfway through the circle is length 1. Which would make, what would this coordinate be if the length of the radius is 1? 1, 0, right? It would be out 1 and up nothing. Okay, so the length of the radius is 1. That point has to be 1, 0. Okay, and then I guess it would make this point 0, 1, right? This point would be negative 1, 0. And then the bottom point would be 0, negative 1. Okay. Now, this is a very special circle. It's used in a lot of different scenarios. And because it's used so well, this is called the unit circle. Okay. Now, it's called the unit circle because, well, if you go out 1 anytime, you're going out 1 unit. So it's a circle that goes out 1 unit, basically. Okay. All right, we're not going to learn everything about the unit circle today. There's a lot of stuff to learn about the unit circle, and you'll probably be tired of it later on. But we're just going to go through and figure out what the degrees are. And that's not too hard, okay? So we already know a couple of degrees here. I know that this is 0 degrees, right? That line there is a 0 degree angle. We already know that this is 90 degrees. We have the 180 degrees, and we have the 270 degrees. Okay, those are the ones that we've known, and we were able to figure out what the angles are immediately. Okay. Now what we're going to do is we're going to try to figure out what the other ones are. Okay. Let's talk about this one here. I think this one's a little bit easier to talk about. Can anyone guess what that angle is going to be?
45.
45, right? And how'd you get 45?
That's half of 90.
Yeah, right. I'm splitting 90 in half. That line kind of bisects the 90 degree angle. So 90 divided by 2, this is a 45 degree angle. Okay. Now, that goes for all the middle angles, right? Between 90 and 180, we have 135, right? That's halfway between 90 and 180. Halfway between 180 and 270 is 225. And halfway between 270 and 360 is 315. Okay. So we have a couple of these angles. All right. Now let's think about these guys here. The two left on the first quadrant. What do you think those angles are going to be? Yeah, how should you get those numbers?
It's 2/3 of 90, so 60.
Yeah, exactly. So I think what Marissa saw is, okay, I know those two angles. What they're doing is if we ignore that 45 degree angle, it's kind of cutting the unit circle into, and you don't have to do this on your paper, into thirds, right? We got 1/3 at the 30 degree angle. We got a middle third, which the 45 is kind of cut in half. And then we have the other third section there. Okay, so what the other two angles are doing is they're splitting the 90 degree angle into thirds. Okay, so then Marissa was like, okay, I'm just going to divide 90 by a third and then by 2/3, right? So she got 30 degrees and 60 degrees. Okay. Okay. Well, we can do the same with the other ones, but it's a little bit hard to divide something by thirds. How do you think I can get this angle here? The one on the second quadrant. At 30, right? I know that the other quadrants are doing the same thing. And I know that it splits it up in the same way. I know that this is another 30 degrees, right? So I'm sectioning everything off into 30 degrees. So in order to get this angle that I just marked over here, I can take 90 and add 30, and that gives me 120 degrees. Okay, so 120 degrees. Okay, so I'm not really asking you to go around and memorize every single angle of the unit circle. You can literally just add 30 to every angle and figure out what the other ones are. Okay, what would be an easy way to find this angle here? You can add 30 again, or you could even know that 180 is on the left. And I know that this is 30 degrees. So you can either add 30 or take 180 and subtract 30, right? So that would be 150 degrees. Okay. You know what I want you to do? I want you to go around and figure out the other 4 angles here, either by adding or subtracting 30, just to kind of get your brains working on finding these angles. All right, I think we're doing good here. If you're still working, that's okay. Let's talk about the third quadrant real quick. What did we get for this angle in the third quadrant? 210, good. And do you remember what you added to get that number? 30 to 180, right? So you did 180 plus 30. Good. All right. What about this angle here? The one left in the third quadrant. 240, good. Okay, so that one's 240 degrees. Okay. Finally, in the fourth quadrant, can someone give me the last two angles in the fourth quadrant?
300 and 330.
Good, 300 and 330. Okay, so those are all the angles here. Okay, now I forgot one more very important angle. 0 degrees is the same thing as 360 degrees, right? Okay, going all the way around the circle. Okay. Now, I don't know if it's obvious to you yet, but I don't think I explicitly explained this. How would I find the angle 135 without finding the middle of 90 and 180? What would I add together to get the 135 angle? Not
45.
15, not 35.
45.
45, right? I know that this angle is very oh God, didn't mean to do that. This angle right here, and let me kind of highlight it. This angle is very similar to the 45-degree angle. So instead of finding the middle, you could have also done 90 plus 45 to get that angle, okay? Does that kind of make sense? All right, so these are the very important angles on the unit circle. I'm not going to tell you to memorize them because I feel like there's a lot of angles to know here. What I do want you to know is to know how to be able to find all these angles, right? So know what numbers to add together to get the other ones. Now, you should probably know the 90, the 60, the 45, the 30, the 0, right? Those are ones that you should know, or at least memorize those angle measures. But the other ones, I just want you to know how to find them. Okay. All right, now we're gonna make things a little bit harder, which is great, right? Let's flip to the next page. I'm going to introduce a new thing that I feel like is very confusing at first, but makes a little bit sense why we're even talking about it. Let's talk about number systems, okay? Normally, when we count in math, we have 10 fingers. So I think the Babylonians were the first to use a base 10 number system. Since we have 10 fingers, usually when we count by tens, right? So when we count money, usually we count by tens, right? We have 10 fingers, things like that. I think the Babylonians also used a base 60 number system, which is weird. So instead of like counting money by tens, they would count money by 60s. And that's kind of like their base of counting. Okay. It's kind of weird that we have 360 degrees in a circle, right? It's not 10. It's kind of weird. And we have to think about, okay, the quarters of 360 and things like that. And that's why it's a little bit hard to think about them since there's so many different degrees. We know that there's 360 degrees in a circle. Does anyone know why there's 360 degrees in a circle? All right, I'll give you two reasons. Okay, so there's two very historically, two reasons why we use 360, why that's a very special number. The first reason is 360 is a very good number to divide by or to divide things from. Okay, so let me write this out. 360 divides many different numbers. What I mean by divide is when you divide it by something in a calculator, it gives you a whole number. Okay. For example, I could divide 360 by 1 and get 360, whole number, not a fraction. I could divide 360 by 2, right, and get a whole number because, well, it's even. I could divide 360 by 3, right? 36 is divisible by 3, so 360 has to be divisible by 3. It's also divisible by 4, 5, 6. It's actually not divisible by 7, kind of a weird thing, but okay. But it is divisible by 8, 9, even 10, and so on. Okay, so it factorizes really well. which means it's very useful. So dividing a circle in many different ways is really important, especially when we're dealing with angles and things like that. So that's one of the reasons why we use 360. The second reason we use 360 is sailors. Okay, sailors are the reason that we use 360 degrees for a circle. Okay, and how I'm going to explain this is let's pretend we're a sailor. Okay, so we're on a boat. We got a little flag, and we're on the sea. Okay. I know, amazing math class, right? It turns into drawing class. Okay, let's think about boats for a second. When we drive a car, when we drive around and we want to know where we're going, usually we'll turn on the GPS or something and it'll tell us, turn by the store or turn at this street or something like that. Sailors don't have that, right? Sailors don't have a street or a landmark to figure out where in the world that they are. So how do sailors know where to go if there's no landmarks around? What do they look at? The constellations. They look up in the sky and they look at the stars, right? Okay. So they look up in the stars and they know that there's a constellation up the sky and they're like, okay, because of that constellation, I know where I'm going. Okay, so those are their landmarks. Okay, at least back in the day. Now they probably have an idea of where they're going, right? Okay, well, stars are really important and they're really great to use, but they're not consistent, right? Let me explain why. Okay, and the way I'm going to explain this is maybe use my colors a little bit. Let's draw the sun. Okay, so here's the sun, and I'll draw the earth. I think the earth, let's say it's here. Okay, so let's say we're a sailor and we're on the earth, and the earth goes around the sun in kind of like an elliptical shape. Okay, and I drew the earth here because we're a sailor and it's nighttime, right? So it's nighttime, which means maybe I'm a sailor and I'm right here. Okay, so because I'm on the other side of the earth, I'm looking out at the sky and it's nighttime, right? If I look this way, it would be daytime. Okay, so that's the earth. I'm on the nighttime side of the earth. Okay, so at that point in earth, I'm looking at a very certain set of stars, right? So there's a bunch of stars in the sky that I'm looking at. Okay. Now, okay, I'm traveling around the sun in, I don't even know what direction. And then let's say, I don't know, a couple of days later, I'm over here. Okay, so I'm over here now. Okay. I'm still looking out at the night sky, but I'm not seeing the same set of stars, right? I'm seeing a whole different set of stars. They're over there now, okay? Because of this, well, stars aren't very consistent, right? I have to think about where I am in position relative to the sun to figure out where I am based on what the stars look like in the sky. Okay, now, let's say I went 365 or about 360 days later. Okay, I'm going to be traveling. Oh, I wonder if I can do this. Oh man, let's see. Oh no. Okay, let me do this. Okay, this is just because I just want to have fun now. Let's say I'm traveling around and 360 days later, I'm back where I'm at, right? And then I see the same set of stars, okay? Well, because of this is why we basically use a 360-degree number system whenever we talk about rotations. Because whenever we rotate around the sun, about 360 days later, now I know it's 365, but sailors back then kind of approximated it to 360. This is why we have 360 angles in a circle, okay? That's the only reason that we use 360. It's a historical sort of reason. Okay, now, well, there's really nothing mathematical about 360 being the set number of angles in a circle. And I'm actually going to write that out here. So I'm going to write this out. There is no inherently mathematical reason that makes 360 degrees in a circle a better choice. Okay, there's really no reason other than the fact that it factors really well. There's really no reason why 360 degrees is better than any other number that we use for a degree in a circle. And because of that, mathematicians like to make things a little bit more complicated, okay? Instead of just going with what we've always went with before, what sailors have used back in the day, what Babylonians have used way back, mathematicians use radians, okay? Has everyone heard of a radian before? I think we've kind of heard the term, right? We'll talk about what radians actually are, but before I even talk about that, let's talk about calculators, okay? We're going to be doing a lot of functions that take in angles, and a lot of you will use your calculator for that, and that's okay. But the problem is there's a radian mode on your calculator, and then there's a degree mode on your calculator, okay? Now, if you are doing something that has a degree and you're in the radian mode, the calculator is going to give you the wrong answer, okay? On the other hand, if you're using radians and your calculator's in degree modes, the calculator is also going to give you the wrong answer. I think a lot of you have different calculators that you have. So what I'm going to do is I'm going to give you a little bit of homework over this week. What I want you to do is to figure out how to switch between radian mode and degree mode on your calculator, okay? Basically, what I'm going to have you do is go to YouTube. YouTube is a great resource. It tells you a lot about different types of technology. I want you to look at your calculator and see like what it's called. Okay, usually it has like a name to it, like TI-84 or TI-86 or something like that. Just look for a video that explains how to translate between degrees and radians, okay? Just watch that, try to know how to translate between them. If you don't have a calculator, it's fine. You don't have to have a calculator in this class, but it does help, especially when you're doing homework and stuff like that, to know how to type stuff in your calculator. Okay, so little homework assignment for you, just know how to switch between the two on your calculator. All right, let's go to the next page and figure out what in the world radians are and how we use them, okay? Okay, before we talk about radians and how many there are in a circle, let's go back to the unit circle, okay? So the unit circle looks like this. It's a circle with the radius 1, which means if you go out on any of the axes, the circle will stop at 1, right? Okay, and let's talk about the circumference. Okay, remember the circumference of any object is how long it is on the outside. So if I was walking around the edge of the circle, how long would I walk around? Okay, I know this is taking it back a few years, but does anyone remember the circumference of a circle? It's a formula for it. And that's for the area, but very close to 2 pi r, right? The way I memorize it is really stupid, but area squarea, and then the other one circumference. So circumference is 2 pi r. Okay. Now, what's the radius of the unit circle? Not 1 pi, it's actually just 1, right? So the unit circle goes out 1 on the left and right. So the radius of the unit circle is 1. So what's the circumference of the unit circle? If r is 1, 2 pi, right? Just plugging in 1 gives me 2 pi. Okay, so the circumference of the unit circle is 2 pi. That's how much it would take me to walk around. And that's actually a good representation of figuring out the angles, right? Because we're going around the circle. Okay. Because the circumference of the unit circle is 2 pi, how many radians do you think there are in a circle? Well, 2 pi, right? So the radians just represent how long it takes to walk around the circle, and that's it. Okay. So this is a mathematical definition of an angle, right? Which means it's a little bit more mathematical than just saying, oh, there's 360 degrees in a circle. That's it. Okay. We're actually expanding our definition into something that's a little bit more mathematical, something that we can actually work with. Okay. So because there's a 2 pi radians in a circle, let's talk about the really important radian angles that we have. Okay. All right. So our first angle is an angle that doesn't actually go anywhere, right? We said that was 0 or 360 degrees. In radians, we're going to say it's 0 radians. Usually, in terms of notation, I'll say 0 rad or just 0. Okay. And instead of 360, we know that it's 2 pi. Okay. So going nowhere is either 0 or 2 pi. All right. What do you think going like halfway around the circle would be? Just pi. And how did you get pi? Yeah, you're going halfway around the full circle. A full circle is 2 pi. Half of that has to be just pi. Okay, so this angle is pi. Okay, let's talk about some other ones. Let's think about the 90-degree angle, right? That's going like a quarter way around the circle. What do you think that's going to be in radians?
Pi over 2.
Yeah, right. We're going half of pi, right? So pi over 2 would represent that angle. And then the last one's a little bit harder, but our 270 degrees, 3/4 around the circle. What do you think that's going to be? 3 pi over 2, right? I'm going to take my pi, I'm going to add on another pi over 2. So that gives me 3 pi over 2. Okay. These are the very important angles that I want you to know in radians. There's going to be others, but we can use these to be able to at least approximate where things are on the unit circle. Okay, let me just take a peek. Okay. Yeah, I think we have time to do example number 4. So let's go ahead and do that. Okay. All right. So same thing with radians as we had in degrees. We can find coterminal angles. Coterminal angles are angles that produce the same picture, but they're just like positive or negative. Okay. So this angle is negative 5 pi over 4. It goes in the clockwise direction, so it's negative. Let's think about how we're going to find the coterminal angles here. All right. How do you think I can find a positive coterminal angle? Yeah, add and subtract 2 pi. In this case, we want a positive angle, so we should probably add 2 pi. Okay, just like we added and subtracted 360, now we're just doing it with 2 pi. All right, so let's do 5 pi over 4, but negative, plus 2 pi. Oh gosh, now we have fractions, right? All right, well, how do you think I can add these two? Yeah, finding a common denominator seems to work. I know there's a pi there, but it's literally just adding fractions. Okay, so let's just ignore the pi for now. Let's do 5 pi over 4, and maybe our common denominator is going to be 4, right? Okay, I know there's going to be a pi on top. What's going to be my new numerator? Not 6, 8, right? We're doing 2 times 4. So 2 times 4 is 8. Okay. Now, subtracting these two together, we have 3 pi over 4. Okay, so this is one of my positive coterminal angles. Okay. Now, how many of you have like fancy calculators? I see, yeah, a couple. Let me show you a trick on how to do this with the fancy calculator, okay? Now, if you type in negative 5 pi over 4 plus 2 pi in your calculator, I don't think that's going to work. But what you can do is you can just add, okay, let me write this out. You can add negative 5 over 4 plus 2 in your calculator, okay? Now, if you do that, you're going to get a fraction. You're probably going to get like 0.75. Okay, now if you don't know what fraction that is, I think there's an option in your calculator. There's a button that says to frac.
Yeah, you have to hit math and then enter.
Okay, math, enter, enter. Okay, so that will make it, that will make this symbol appear in your calculator after that. And then you just hit enter and it'll give you 3 over 4. Okay, now once you get 3 over 4, you know there's a pi next to it, so you can do that in your calculator if you want. Okay, let's find the other positive coterminal angle. What do you think I'm going to do to get the other positive one? Plus 2 pi again, right? Now, it's probably not a good idea to start with the original angle here because then I'm going to have to add 2 pi twice, which is kind of dumb. I already have 3 pi over 4, so I'm just going to take the 3 pi over 4 and add 2 pi again, right? So finding a common denominator looks like the common denominator is definitely going to be 4. What's another way of saying 2 pi is a fraction over 4?
8 pi over 4.
8 pi over 4, good. And now the denominators are the same, so when I add these together, I'm going to get 11 pi over 4. Okay, so that's my other coterminal angle for this one. All right. Any questions on part A? All right. You know what? I think I'm going to leave the negative ones for next class. So let you out a few minutes early. I will see you on Wednesday. We'll talk about radians some more. Alrighty.